This is Geometry Lesson 1.3. We're going to start talking about lines and angles in relation to each other. So again, we have a lot of words to define. I'll go through these. I'll just read through them and you can pause as you need. The first word we're defining is parallel. Parallel is when two lines or rays or segments do not intersect. So they're going the exact same direction. Doesn't matter how long they are. One can be short and one can be longer if they are segments, but they would go the same exact direction. When we notate that they are parallel, we put a little arrow on the line, or two arrows or three arrows as long as they match to show that they are parallel. And then the symbol for parallel, we could say line L is parallel to line K. So two bars like that means parallel. My next word is perpendicular. Perpendicular is lines that cross at a 90 degree, also known as a right angle. So I have one line here, line B, one line here, line A, and they are intersecting, but they are intersecting at a perfect T. So that little square tells me that that is exactly 90 degrees. Our symbol for perpendicular looks like an upside down capital letter T. So this reads line A is perpendicular to line B. My next word is right angle, and I kind of already gave that one away. A right angle is a 90 degree angle, and a 90 degree angle is that perfect L. You can either notate that by putting a square in the corner or putting the number 90 in the corner, or you could do both. Some people like to do both, but that's how we show a 90 degree angle. Our next word is acute angle. An acute angle is an angle that is less than 90 degrees. So think about taking that perfect L and squishing it down a little bit. That would make the measurement less than 90. It hasn't opened up to its full 90 yet. That's an acute angle. And I always think the word acute, acute small angle. The next word is an obtuse angle. An obtuse angle is an angle that's greater than 90 degrees. So again, think about that perfect L, and then you would open it up a little bit wider. That makes an obtuse angle. Complementary angles are angles that add up to 90 degrees. So I have two examples here. I have a 40 degree angle and a 50 degree angle. Put together, that would be 90 degrees. I have a 20 degree angle and a 70 degree angle. Put together, that would be 90 degrees. My next one's a supplementary angles. Two angles that add up to 180 degrees. So here I have a 120 degree angle and a 60 degree angle. Put together, that's 180 degrees. Next is vertical angles. So when I have two intersecting lines like this, the angles that are directly across from each other would be vertical angles. So that can be on the left or the right, or the top or the bottom, or if it's a little askew, the northeast corner and the southwest corner, but they have to be straight across from each other. And then the last one is kind of the same picture, but the different pair of angles. So linear angles are angles that are next to each other on two intersecting lines. So right here I have this angle on the top and this angle on the left. They are right next to each other. Even if I don't extend that line, if I just have a ray there, it's still two angles that are right next to each other. Okay, one quick example. We're going to mark the information given in the question. So here I have a rectangle looking shape. We haven't defined rectangle yet, but it says here AB is parallel to CD. So I have AB on the top, CD on the bottom. To mark that they are parallel, I just added these little arrows. Next I have AC is perpendicular to CD. So I have AC on the side here, CD on the bottom here, and I put the little square to show that they are perpendicular. I could also put the number 90, but I like the little square. The last one says the measure of angle B is 90 degrees. Anytime you see a little lowercase cursive or italicized M, that stands for measure. So measure of angle B is 90 degrees. So I threw a 90 in the corner of angle B. I could have done a square. They're both correct. It's up to you. Next example says segment BW is congruent to segment TI. So BW right here, and TI right here, I added that mark on both sides. WO is congruent to IO. And so since these are congruent to each other, but not congruent to my original segments, I did 2 marks instead of just the single mark that I did the first time. If I had a third segment congruent statement, I could use 3 marks, or a fourth, I could use 4 marks, as long as they match up. Now we're going to mark some angles congruent. This is angle WBT is congruent to angle ITB. So remember, the middle letter in each of these is the vertex. B is the vertex and T is the vertex, so that's where our mark's going to go. WBT is this angle right here. So I add my congruent mark at the vertex B. My second one is ITB. ITB, so I add my congruent mark right there. My second angle congruent statement says BWO congruent to TIO. So here's BWO congruent to TIO. So I put my 2 mark in this corner and my 2 mark in this corner to show that those 2 angles are congruent. That is it for the examples and notes. Good luck on the exercises, and please let me know if you have any questions.